Okay, so let us talk about Mohe Circle. Mohe Circle. Okay, let me just double check. Hello. Okay. So what exactly the deal with the Mohe Circle? The whole point is that we actually want one diagram, that one diagram in which if I draw, we can just have a look at it, and after having a look at that diagram, immediately I would have an idea of what are the different stresses on different planes. Because right now what happens is I have to say what is the stress at 40 degree or 50 degree or 70 degree or 80 degree or 130 degree. And you will keep on using those stress transformation equations. But we want one diagram. One diagram, I have a look, and immediately I will have a complete idea of how the stresses are probably behaving or stresses that are appearing at different planes. So how to make a Mohe circle? Number one, what you will do is Mohe circle will be the answer to our question. The first step is find the center of circle. Find the center of a circle. And just remember one thing, that we will be using this mostly, I would suggest, for two-dimensional stresses, which is pretty much what we will be doing mostly in this semester. So if you have two-dimensional stresses and you have a look at Mohe circle, then you will have a complete idea of how the stresses are behaving in the overall, in pretty much every other plane. So the center of the circle will be your stress average. Number two, you have to find the radius of Mohe circle. Okay, so let me just go over a simple example and let me tell you the radius formula. The radius R is given as square root of stress X minus stress Y over 2 square plus tau xy square, and stress average is stress X minus stress Y divided by 2. So let us do a simple problem. Let's say this is your question. The question says this is your y-axis and this is your x-axis. Now this is our 10 megapascals, let's say in the question, inward. And this is 40 megapascals outward. And we have, I'm sorry, it's not 40, it's 50. Please correct the mistake. And the shear stresses are 40 megapascals. Anti-clockwise, so this should be clockwise, right? I suppose clockwise. Okay, so 40 megapascal, 50 outward, and 10 inward. Okay, so let's draw a Mohe circle. Number one thing, you will find the center of the circle, that will be average stress. So why don't you tell me the average stress using your calculator today? Tell me the center of the circle, please.
30.
Why 30? 50 minus 10, 40 divided by 2. Oh, sorry. Okay. Sorry, it is my mistake. I apologize. Sorry. Stress X plus stress Y. Sorry. So I think I made a mistake. Average should be this plus this divided by 2, not minus. So I think one of the students said, so it will be 50 plus minus 10, 40 divided by 2. So it will be 20 in our case, because the formula is stress X plus stress Y divided by 2, and the stress Y is negative. So 50 minus 10, 40 divided by 2. Huh? Everything is, the radius formula is correct. Radius is 50. Ach. So let me put here 20 as one of the students told us. And one of the students said 50 here. Okay. So the first thing that you will do is you will put this center at 20. Okay. The second thing you will do is you have to understand that the x-axis has normal stress and the y-axis has shear stress. But what will be very funny is that the positive y-axis will have negative shear stress and the negative y-axis will have positive shear stress. Is it clear? Ghazal, right? Negative top, negative y-axis, and the positive will be negative y-axis, and negative tau xy is on positive y-axis. Questions? No questions for me? Okay. Now, what you will do is, let's say, I connect them. So your center, students told me, is at 20 megapascal. Then where will be the coordinate system? Your coordinate system will be somewhere here, right? In fact, I think I can draw the pink line little straight. So we will have, this point will be our origin. Now, this is very confusing, right? Your average stress is at 20 megapascal, right? Then your origin 0 is this line. So now you can say that this is my 20 megapascals. Okay. 20 megapascals. So this is your origin and 20 megapascal to the right is your center. Now, what was the radius? 50. So if I ask you, what will be the value of this point? Any student who wants to make a guess. If this is your origin, 20 megapascal is the average, is the center of the circle. The radius is 50 megapascal. Then what will be the value of this stress? 20, and this is radius 50. This will be, thank you, 70. Okay, then next question is, if this is the point, the origin is 0 is this one, then what is the distance from origin to this point? 30. How much? 30. let's do it together. So radius is 50, total 50, and this is 20. No, 30 or negative 30? Negative 30. Now your answer is correct. Good. Okay. The next question is, what is the definition of principal plane? What was the definition of principal plane? So principal plane was the plane in which we had maximum or minimum normal stresses. And what was the shear stress on the principal plane? Last time we did it. The shear stress was 0. So on this line that we have, what is the shear stress? 0. So technically, this is our principal plane, and this one will be stress 1, and this will be stress 2, your maximum and minimum normal stresses. Okay, the next question is, so just one, you can call it correction. This point is minus tau max. Because this line has, I'm sorry, the y-axis is giving us tau xy, but those extreme points are tau max. So any student who can tell me what is the value of tau max? What is the value of tau max? Huh? Anyone?
40.
Why 40? Hamza can also try, by the way. What is the value of tau max, Hamza? Bahadur, Ebu, Ghazal? What is the value of the tau max? What is the radius of the circle? 50. So 50, nahi? 50. It's very easy. I'm a little surprised that nobody guessed it. 50.
What about 40 megapascal?
50. What?
Where will we use the 40 megapascal?
The one that is given in the question?
Yeah.
Good question. We will figure out in the next 5 minutes. That 40 megapascal, Bahadur, that 40 megapascal and that 50 megapascal and that 10 megapascal that is given in the question, right now you don't see it here. Right? On this circle right now, you cannot see, right? Like if I ask you, where is the 50? The normal stress X, you cannot see on this circle. Where is the negative? I haven't even drawn all of that. So now the next task right now is I will be drawing it. So what just Bahadur said, we will start drawing that. So,
Sorry. What is Mohe Circle?
Yeah, I did explain that in the initial 5 minutes, but no worries, I can do it again. So in the first 5 minutes, when I started the class at exactly 10:40, what I said was that we actually would love to have Mohe Circle, a diagram that the moment I look at it, I will have a complete idea of how the stresses are behaving on each plane. So previously I used to use stress transformation equations, and I used to tell you, this is the theta, give me how the stresses are behaving on this particular plane, which is sitting at theta equal to 37, 45, 55, 175, whatever. Now what I'm saying is I will make a circle, and that circle will have pretty much every plane, and I will just look at it and I will have an idea.
So we turning the principal planes and we drawing a circle and we looking at in which principal plane we have which shearing.
No. Principal plane is just principal plane. There is only one principal plane, and I have told you where that principal plane is. That principal plane is this line. This is the principal plane. It's not like different principal planes. There is just one principal plane. I have drawn it. But what I'm saying is now I want to draw these different lines, and each line will give me an idea of how the stresses are behaving on that line. So just to answer your question, right now, the number one thing we will do is we will draw the stresses that are given to us in the question. Okay, that will answer your question. So in fact, you can help me. the given question says that the stress X is equal to 50 megapascal. So why don't you all help me with that? Where is stress X equal to 50 megapascal? So this is origin, right? Origin has 0, right? Okay. Now I have to find a 50 megapascal. So where is 50 megapascal? 50 megapascal. This is 20 megapascal. This is 70 megapascal. Where is 50 megapascal? Between them, na? So I think if this is 20, this is 70, 20, 30, 50, 50, 20. Where should I draw? Somewhere here, nahi? In fact, you can all help me. So this is 20. This is 50 should be a little toward the right or the left. In fact, I'm genuinely asking it because right now I don't understand. Here somewhere, huh? Okay. Everyone has told me that 50 should be here from the origin. So I will agree to them. And now I will draw. Let me use a very nice, let's say, light blue line. Okay. My next question is, on this 50 megapascal, what is the value of shear stress? Hamza will also help us. Is it positive 40 or negative 40? Positive 40, na? So positive y-axis is positive tau or negative y-axis is positive tau? Negative y-axis is positive tau. This is very confusing. So I will go, I have found 50 megapascal because all of you told me this, because everyone was telling me that the origin is 0, 0. That's why they took me to 20 and then here. And then everyone said, why don't you go to the negative one? So this value is my point, which is 50, 40. Okay. So I will be answering Mehmet's question. This is the first part to your answer. But before I answer your question completely, why don't you give me negative 10 megapascal and clockwise 40 megapascal? Give me negative 10 megapascal. Okay, in fact, you can help me. If this is 0, 0, then where is negative 10 megapascal? To the left, right? So I will again use the blue color. Negative 10 will be very, very close to this one. Okay. Now tell me, clockwise means negative 40 megapascal. Negative 40 pascal will be in the positive y-axis or negative y-axis? Positive y-axis. So you will circle this point.
Can you explain the reason again for like upwards being negative?
No, there is, I'm not sure how to give the reason of why the negative tau is on the positive y-axis. Once you draw this, everything will fit together if you have negative shear stress in the positive y-axis. I'm not sure how to come up with a y in Mohe circle. In the positive y-axis, we have a negative shear stress, but everything fits together like that. Huh? So I'm sorry, I couldn't come up with the. Okay, now I will be answering Mehmet's question. Look, the most important piece is you connect the two dots together. Oh, that's not good. I think I made a mistake. So I will correct myself because it should go through the center. So no worries. No, take a minute. Let me, one second. I will answer your question. 50, 40.
Should be minus 20.
This is negative. Wait a minute. Now I think it is correct. So let me, sorry for that. let me, okay. Now we will do it again. What was the value you told me? -10 and -40. So we will go, this is negative, this is 0, 0. So this is our -10. And this value is -40. Okay, now it's fine. But the line should go through the center of the circle. Okay, let me just connect it with a beautiful blue line. Okay. So I think it makes sense because this little distance is -10, but this big distance is 50. Anyways, it doesn't look up to scale because I couldn't make up to scale. Now you can ask me questions.
So where does that -10 come from?
-10 megapascals.
Why is the x coordinate? Is it not one?
No, the stresses, the normal stresses are on the x-axis, and your shear stresses is on the y-axis. So what I did is I drew the positive 50 megapascals. I started from the origin. I went all the way up to 50 megapascals, and I drew 50, 40. Then I started from the origin and I went to the negative. I got a -10 value. Okay.
Joe, which one is the real origin in?
This is your origin. This is the origin, the O.
Oh, but the infinite line coinciding with the
Center of the circle.
center of the
This should go through the center of the circle, but your origin is this one. So you have to find the center of the circle. You found it at 20. If the center of the circle is at 20, the origin has to be on the left of it, right? So origin will give you a 20 here. And then you will always use your origin for everything.
So this is just a diagram, right?
Yeah, this is a diagram.
Okay.
Okay, now the next question is, what is the theta p? The next thing that you have to realize is that the angles on the Mohe circle are 2 times the actual angles. So for example, why don't you first of all use the direct formulas and tell me tan 2 theta p. What was the formula? 2 tau xy over stress x minus stress y. So first of all, give me theta p from here.
Nine.
20?
Nine.
No, 26.
6.5. 26.9.
Yeah, I have 26.6 in my notes. Whatever. Okay. Now, the biggest question is, can we find this theta p from the Mohe circle? The answer is yes. What this theta p used to tell you was that where does your principal plane lie with respect to what is given to you in terms of the stress x and stress y. So 26.6 degree means that you have to go anti-clockwise, right? And you will find the principal plane. Every angle on this Mohe circle is 2 times. So we can actually find this theta p from here. Where is your principal plane? This line, right? Okay, and where is your stress x comma, where is your given stress profile? That is this black line, right? So actually what you have to find is you have to find the angle of this line with this purple line. So essentially I want you to give me this angle. In fact, the funny part is, in fact, I will first of all remove this. I don't want you to see this. This will be your 2 theta p, not theta p because every angle on Mohe circle is 2 times. Why don't you give me tan 2 theta p using this? So it will be perpendicular over base, right? So let us remove this formula. Okay, what is perpendicular? It will be 40. Okay, what will be your base? No, not 50. From here to here, it is 50. This is 20, 30. Who said 30? I think he said it and Ghazal said it. And very good. Perpendicular over base. Now give me theta p. Same number. Sure. Okay. Double check. Okay. So if theta p, this 2 theta p comes out to be 52 point or 53 point, whatever. So yeah, this was a nice and beautiful Mohe circle. Now, in fact, you can actually use this. If I ask you, give me the stress at a plane that is, let's say, 35 degree from this one. So you will actually draw a line 70 degree anti-clockwise from this line, and you will start playing the same game. So essentially, Mohe circle can help you, give you the stresses and everything on different planes. Okay. Why don't you also give me one more thing? What is the normal stress that is acting at? Give me find or determine the normal stress, the normal stresses on planes that have maximum shear stress. Give me the value. Okay, where does the maximum shear stress lie? Huh? On the bottom and on the top, right? What is the value?
On the top of number is minus.
Yeah, that's fine. But it's still maximum shear stress, right? Magnitude or whatever.
But some can you remove the
Okay. So just tell me, what is the value of normal stress on the plane that has the maximum shear stress?
0.
No. Where is the maximum shear stress? Good. Good answer. This is tau max, right? So you can, this is your origin. What is the distance? 20 megapascal. What did I write here? 20.
Yeah.
So right here, 20 megapascal. Okay. I wrote here.
That's the normal stress at the maximum shear stress.
Yeah, and what is the reason? Because you can see that this is the center of the circle. Center of the circle has 20 megapascal, and center of the circle has this line, and the top of this line or bottom of this line has negative 50 or positive 50. So this negative or positive 50 has what normal stress? 20 megapascals. Okay, so I will give you a homework assignment and you will play with this Mohe circle. Again, you can have an idea that you can find the radius of the Mohe circle, right? And 20, the stress average plus radius of the Mohe circle will give you the maximum principal stress. And the average stress where it is, this 20, right? What was the technique? Yeah, minus the radius will give you the stress 2. Yeah, average stress plus radius gives me 70, and average stress minus radius gives me stress 2. So what you can do is you can actually draw a few drawings. So number one drawing that I will draw is this one. This is what was given to me, correct? And what was given to me was 10 megapascals negative, and 50 megapascals positive, and then let me draw some pink lines for 40 megapascal. This was the question, right? If you remember. Did I change the question? Give me 1 second. Yeah, 40. Why did I put a 50 here? Oh yeah, because this is maximum shear stress. I'm sorry. And that's the maximum shear stress. Pretty much the same question as Bahadur asked me. Where is the 40? So I actually also for 1 second thought. Anyways, 40, and this is given question, and this is clockwise. Now you can just draw a few lines. So the first question that I can ask all of you is, what is the value of theta s just by looking at the drawing? Mohr circle. Anyone? Give me the plane of maximum shear stress, theta s. How would you find? This is the black line, right? The one where your stress is given to you. Where is the plane of maximum shear stress? This line, the pink line. So this will be your theta s, right? Everyone? No? Okay, so give me this value. This will not be theta s. This will be 2 theta s, because everything on Mohr circle is 2 times. So now you can have what? You already found it? I don't know. I don't have the value. So I will find it with you. So what you can do is you have to find this. So it will be perpendicular over base. So what is my perpendicular? What is this distance? It is 30, right? And similarly, what is this distance? 40. So I will have perpendicular over base. And what is the base? 40. Okay, give me theta s now.
Hocam 18.4.
18 point. Sorry, 18 point.
Four.
So why don't you do one more thing? Go back to your notes and use the tan 2 theta s formula and tell me, do you get the same answer or not? Do you remember that formula?
No.
Okay. Let us go back. I showed you that formula. Where did I write that?
The previous one, this one.
Yeah, tan 2 theta s is equal to minus stress x minus stress y divided by 2 tau xy minus stress x minus stress y divided by 2 tau xy. So minus stress x minus stress y divided by 2 tau xy. The stress x is 50, stress y is negative 10. So minus stress x minus stress y divided by 2 tau xy. And the value of tau xy is 40. Stress x is 50. No, no one is doing it. Minus stress x minus stress y over 2 tau xy tan 2 theta s equal to. So stress x is 50. How much?
Minus
18.4. Oh, that's fine. Very good. Minus 18.4 is correct, right? Why? Because look, you from this black line are going in clockwise, right? So your formula tells you that the plane, your plane, you have to go clockwise 18.4 to find the plane of maximum shear stress. And we are also finding the same thing, that we have to go at 18.4 degree in the clockwise sense to get this. So our direct formula is correct and we are also correct. And in 2 theta p, we had to go anti-clockwise. Okay. Yeah, before I take your question, there is one more thing. You can add, let's say, 180 degree to this 2 theta s, and you will actually arrive on this plane. Yes, please.
What is the purpose of the theta s?
The plane of maximum shear stress. So if this is the given stress profile, where does the maximum shear stress plane lie? So theta s lies negative 18.4 degree.
So we initially draw the first condition in the Mohe circle.
Which condition? This one?
The initial condition.
This one?
Yeah, we give the values in Mohe circle and showing the diagram. And we found that in order to find the maximum shear stress and minimum maximum normal stress and minimum normal stress, we need to turn the normal, we need to turn the square into theta p.
Good. Yes, you are right.
In order to find the tall max, we need to turn.
Absolutely. In fact, I will, yes, I'm about to make this here. You are right, actually. So I will actually elaborate what you just said, that we have to turn. So I will turn. This is theta s. We have to turn negative 18.4 degree. So now I will draw the same square one more time. So this value is 20 megapascals. This is again 20 megapascals, as you all told me. This is again 20 megapascal.
shear stress will be 50 megapascal.
This is absolutely 20 megapascals. And this one will be 50 megapascals. Okay, clockwise. And then we will actually also make the principal stresses. That is at 26.6 degree. So I will draw the same thing one more time. Let's say this goes like 26.6 goes something like this. Okay, again, I don't have so much space. Probably I can still try. So now I will have, let's say, let me use blue color. Sorry, we have to tilt it. So this is, and this is, and then this is, and then this is, correct? This is negative 30 megapascals. This is 70 megapascals. This is 70 megapascals. And this is negative 30 megapascals. Why 70 and minus 30? Because these are principal stresses. And what is the shear stress?
Shear stress will be 0.
Will be 0 on the principal planes. And this angle is 26.6 degree. And this angle is, what was the angle? Minus
18.4.
18.4 degree. So why this plane has 70 and this plane has negative 30? Because you can see as you go anti-clockwise from the plane, only then you arrive at 70. You go anti-clockwise from here, only then you arrive at this one. So you can call this as S and this is your P. And for homework, for example, I can give you a problem and I will ask you, find the stresses at an element that is 30 degree to this one.
So we will just tilt the
This line you will tilt 60 degree.
60
So in fact, forget about that. What is the value of theta 2 theta p? Okay, let's play this little game. Let's say I ask you right now, at theta equal to 10 degree, give me stress profile by using Mohe circle. Now, there are students who are saying, why Mohe circle? You can actually use the same stress transformation equations that I taught last time, right? Stress x prime equal to, and stress y prime equal to, and tau x prime y prime equal to. In place of theta, just plug in whatever I'm asking you. What did I say? 10 or 10? Theta equal to 10 and it will give you the answer. But by Mohe circle, you can also do, it will take more effort from Mohe circle, but you can do it. So theta equal to, let's say positive or negative, let's say positive 10 degree. Let's say positive 10 degree. I don't know, I don't have that in the notes. I will have to try with you. So probably I can try with you. Okay. It will take a lot of effort, but all of us can try. If I have to go anti-clockwise, let me use let's say this green line. So 10 degree means on positive 20 degree on the Mohe circle, and you will go from the black line. So let's say this is approximately 20 degree from the black line anti-clockwise, not clockwise, because it gives you positive 10 degrees. So I'm going positive 20 degree. Now you can mark this point and you can mark this point, correct? Okay. The next task is that you have to find this, correct? So let's do it together. If this black line is at what angle? 2 theta p. That is 26.6 multiplied by 2 is 53.2. 53.2, right? So if this line is 50, if this angle is 53.2, then this angle is also 53.2, right? So 53.2 minus 20. So this angle will be 53.2 minus 20. Kitna? 33.2? Correct? Okay. Now do.
So I think it will be 20.
Minus 20, I said.
Well, yeah.
53.2 minus 20, because we are going anti-clockwise 20 degree. From here to here, I went 20 degree.
Okay, the normal condition is the inclined one. So we turning 20 degree up. Right now I get it.
What did you say? Normal condition.
Yeah.
This black line is my stress profile.
Yeah, this stress
Okay.
profile. So when turning 20 degree in positive direction,
Anti-clockwise.
therefore the
I went 20 degree anti-clockwise. Okay. Yes.
So can I ask something? Is 20 degrees to theta s here in this case?
Sorry.
Where did the 20 degrees come from?
I gave you 20 degree. I said give me the stress profile at theta equal to 10 degree.
No, but you said theta is, there's two types.
There is only one theta. This is my stress profile. I want you to rotate it 10 degree.
Oh.
So 10 degree means on Mohe circle it will be 20 degree. Okay, give me now tan theta equal to perpendicular over base. So next time we will do it, but let me think about it. This is perpendicular. How can we find the stresses?
Also we can use sine and cosine because we know the radius 50, and therefore when we also
Good. How did you figure? I don't know, but very intelligent answer from I forget your name always. Mehmet, let's do it. Good answer. Mehmet said sine 33.2 equal to perpendicular. What is perpendicular? That is your shear stress, right? Divided by hypotenuse is the radius. What is the value of radius? Sure. 50. Radius is 50. Okay. Okay. Give me the value of tau xy, Bahadur.
It's 27.3.
27.3 megapascals. So I will write here 27.3 megapascals. Negative or positive? Negative, right? Negative 27.3. Okay, now I will actually follow the same strategy as Mehmet told us, and I will do cos theta is equal to base over hypotenuse. So again, Bahadur, can you please help me? Because so can you please do cos 33.2 equal to base over hypotenuse? Can you please give me stress xy? 41.8. So I will go here. Now you have to be careful. Is this value 41.8? No,
No.
because your origin is here. So what is the distance of origin if you have to go 41.8 from here to here? And this is 20 distance here. So from here to here, it will be 21.8, correct? Okay. Now do the same strategy for this point. So again, you will do the same thing and you can come up with coordinates here. So you will have positive 27.3 here, but this value will be different. No, this value will be different. You have to find, I don't know.
Sir, can you like emphasize the triangle, please, because I don't understand how we do it by sign.
This is this green triangle. I will answer Hussein your question as well. So first Hussein's question is this one. This is the triangle. So we did sine theta equal to perpendicular over hypotenuse. Hypotenuse is the radius.
How is hypotenuse 50?
Huh?
How is it 50? Like,
Because 50 megapascal is the radius of the circle.
yeah, but that's upwards though. That's at the top, very top.
Radius of the circle is the radius of the circle. Radius can be this one, radius can be this one. Yes, you had a question?
For the sorry, isn't that minus 21.6 and if in the second region if you wrote 21.8?
Oh, hang on. No, I did 21.8 because
No, the minus 21.8.
this one?
Yeah, you wrote 21.8 in second region. Sorry, doesn't it have to be
Negative 21.8.
and did you forget minus?
I don't know. I forgot. I have to double check. So you can tell me again. What was the value?
21.8 in second region.
Here, this one?
Yeah.
I don't know. I think it is 21.8. I can double check for you right now. Look,
Does it have to be minus 20 points?
how is it? So for example, this distance. Yes. Yes. Thank you. Thank you. Excellent answer. This is negative. Very good. Because this distance was, this distance was, what was the distance? 41.8, right? And if this distance is 20, then we have to go. Excellent answer. Thank you so much. I really do appreciate, by the way.
But then I think it's not minus 27.8, it's 27.
No. Actually, the positive y-axis has negative value. That is pretty bizarre. That in positive y-axis we have negative value, but tau xy in positive y-axis we have negative value.
Okay.
Okay.
In the fourth region, so it is 21.8.
The negative 21.8 is correct. Oh, you mean this one? Okay, we will do it together. You mean this one?
Yeah.
Okay, let's do it. So the radius is, what is the value? Everyone, 41.8, right? If this is 41.8 from here to here, and this is 20, then this value will be 61.8. Who said that? Correct. Okay, now you can do this question one more time yourself. Just remember,
So you added
with the origin, because the origin and the center of the circle are different. Look, your origin is here. It is 20 megapascal to the left of the center of the circle. That's why I had to.
Okay. So added with 20 megapascal.
Yes, absolutely. One more thing, everyone. Just remember, what was the question? The question was theta equal to positive 10 degree from our plane of the plane that was given to me. I rotated my plane to 10 degree I rotated my plane to 10 degree. No, this is 20 degree. Why? Because on Mohe circle, everything is, every angle is double. So if I had asked you, give me theta equal to negative 10 degree, Mitch, if I had asked you, give me theta equal to negative 10 degree, what you would have done? You would have gone from here, negative 20 degree to the clockwise and repeated the process. Okay, so now just to emphasize on one thing, in an exam setting, if I ask you, please focus on this point, give me the stress profile at theta equal to 35. If I do not ask you the method, then which is the easiest method? The stress transformation equations. You write stress x prime, stress y prime, tau x prime, y prime, put theta equal to whatever I have asked. You won't be multiplying that with the 2. As it is, theta equal to negative 27, put negative 27 there. Theta equal to 49, put 49 there. And within 60 seconds, you will have the answer. But if I specify, do it by Mohe circle, that's one heck of a job, by the way. Then you really have to go through this drill. And remember, this for Mohe circle, at least what we are studying, and definitely for this Mohe circle, we are talking about two-dimensional stresses. Had I given you stress Z equal to some value, you won't be able to draw this Mohe circle because then you will be completely helpless. And on that note, our class is over. I have to go to the dynamics class for those of you who are taking that course.
Hocam, this is the point of other class. We can do it here, I think, because there is no class.
Yeah, but we never know if someone has booked that class right now. Somebody will come.